Hello, brothers. Can you all hear me at all? Because I can't hear anything. Okay, I can hear you now. Okay. Okay. I think that we are just about ready to start. I know you can't really see it. That's all good. But you see what I want you to see. So let's go here. Okay. So yes, this session is open to all the students. Okay. Let me see how the volume is. So look, it's kind of loud. It's actually pretty good. Okay. Sorry. So I see the delay. I'm listening on another device and I'm operating, so it's like a lot of back and forth on my end. But it looks like it's good. Okay. So, okay, I can't listen to this. It's distracting. So we're going to try to go for a couple of hours. And what this is just a live session for all of my students. But what this is really for, okay, I can't listen. This is really for my College Algebra Hybrid students. But anybody's welcome to join in and kind of join in on the festivities. Now, for extra credit, what you have to do is after I finish this first session, go into the comments. The comments aren't going to post until I get out of the live session. So, after I finish this live session, then it's going to post. Then you can access the comments. Go into the comment section because the live chat, I'm not able to. I mean, I probably am able to pull it up, but I still haven't figured that out yet. Hold on, let me turn this down. All right, so once I kind of close this out and I start on the second one, or once we stop the live session, then you can go into the comment section, and that's where you want to log in. So put your name and your location. I'm not going to see this live chat later on, so kind of keep that in mind. The other thing is, what's the other thing? Oh, so I do give credit for attendance, but I also give more credit for participating during the presentation. So, as we kind of go along, I'll ask questions and I'll kind of open up different opportunities for people to kind of get extra credit. And I'm trying to log it, so you just want to get your name up there as much as possible. All right. So we're going to go for a couple of hours, idealistically, and we'll see how it goes. And I plan on doing another session on Thursday. I know that's going to be after a lot of people's exams, so that's why I was trying to get something today. And maybe the last 30 minutes or so, I'll try to open it for people to ask questions. So you can click on the Ask My Instructor, or just try to get my attention. And, we can try to tackle some people's questions. But this is really just a lecture for my College Algebra Hybrid students. But anybody's welcome to join in and ask questions and get credit. Okay? All right. So without much further ado, let's get the party started. Okay. So this is just College Algebra, and we're going to continue where we left off. I think it was pretty much last time. So in College Algebra, in my hybrid course, we are in section 2.4, linear functions. So we're going to look at graphing linear functions, put it in standard form, what it means, the slope, average rate of change, and linear models. Okay. All right. So a function is a linear function. I think, okay, so that's a typo. That's supposed to be f. That's just supposed to be f. A linear function f is a linear function if f of x equals ax plus b for real numbers a and b. If a is not 0, then the domain or range of the linear function of both are reals. So this is supposed to be negative infinity to infinity. Okay? So what makes it linear? Well, the highest degree on the highest exponent on any variable is a 1. So that's what makes it linear. It's going to be a straight line and things of this nature. Okay, so this asks us to graph, this is f of x, so this is supposed to be f of x equals negative 2x plus 6, right? So we have the solution there. It says give the domain a range and then graph this. So if we're graphing f of x equals negative 2x plus 6, so first we can start by solving for the x-intercept. Now, to find the x-intercept, the easiest thing, well, the way we find the x-intercept is let y equal to 0. So if we're going to find the x-intercept, then we set y equal to 0, right? So if we set y to 0, you see here, let f of x be 0, and then if we solve, we subtract the 6 and divide by negative 2. So negative 6 divided by negative 2 is a positive 3. So the x-intercept is going to be 3, 0, right? Now, if we're graphing a line, to graph a line, we only need, let me turn this down. I feel like it might be a little loud. To graph a line, we need 2 points. So we have the x-intercept, so then the next logical or natural flow is to find the y-intercept. So let's find the y-intercept. To do this, again, we set x equal to 0. Okay. So if we're going to find the y-intercept, okay, so if we're going to find the y-intercept, we set x equal to 0. So then that means that our y is going to be negative 2 times 0 plus 6. This goes to 0, so then it's just y equals 6. So the y-intercept is 0, 6. Right? So then we plot the x-intercept, we plot the y-intercept, and connect them with a straight line. That's what this is saying. So notice here, we plotted the x-intercept, we plotted the y-intercept, and we connected it with a straight line. And again, the domain and range are both all reals. So this is negative infinity to infinity. Okay. So linear is just a straight line. To make a straight line, we need at least 2 points. Once we have 2 points, then we're good to go. All right. So let's keep it going. I don't know if we have any people that do T-Mobile, but T-Mobile has free items on Tuesdays, so for T-Mobile customers. So just check that out. It's called T-Mobile Tuesdays. Just doing a plug for T-Mobile. Why? I don't know. They're not paying me. Why I plugged them? Because the thing popped up and it caught my attention for a split second. Anyway, going forward. Okay. Let's see. I think I had it like that. This example true. All right. I think it's still loading. Okay. Let's see. That's fine. Okay, so it says graph f of x. Again, these are all typos. This is supposed to be f of x equals a negative 3, right? So if we have f of x equals negative 3, what we're saying is that no matter what x we choose, y is always negative 3. So it's just going to be a horizontal line through y equals negative 3. Okay, that's when you have y equals or f of x equals just a number, horizontal line through that number. So again, what it means is no matter what x we choose, y is going to be negative 3. So then for a vertical line, it says graph. Okay, so if we have x equals negative 3, then what that means is that no matter what y value we choose, x is going to be negative 3. So we can plot a few points. We can go x is negative 3, y is 0, x is negative 3, y is 7, x is negative 3, any y that you want. And basically, it's going to be a vertical line through x equals negative 3. So it means that x is always negative 3. So that's a vertical line. Okay. All right. So if we graph x equals negative 3, we're going to give the domain a range. Now the domain is the very left to the very right. Okay, so let's look at this. Say we want to explore the domain of this. So the domain is the very left. So how far left does this graph go? So if we look, it doesn't really go left or right. It only has that one value. So going left and right, they both go to the point negative 3. So the domain is just the point negative 3. So that's why we use the curly brackets. Curly brackets mean that It's just that number. It's no interval. But then when we do the range is the very bottom to the very top, right? So let's look at the range. On the range. Okay. So how far down does the graph go? Okay. So you see the arrow means that it continues the pattern. So it can go all the way down as far down as we want. How far up does it go? It goes up to positive infinity. So the range is negative infinity to infinity. Okay. So does anyone have any questions? Just get my attention. I see the live chat, so just let me know if you have any questions. All right. Moving along. So motion problems, let's see. So in this text, we agree that if the coefficients and constants in a linear equation are rational numbers, then we consider the standard form to be ax plus by equal to c, where a is non-negative, a, b, and c are integers, and the greatest common factor of a, b, and c is 1. If two or more integers have a greatest common factor of 1, they are said to be relatively prime. Okay, let's keep going. All right, we're asked to graph 4x minus 5y equal to 0, okay? So again, the highest exponent is a 1, so that means it's linear. So if it's linear, then we're just graphing a line. To graph a line, the easiest thing is to plot the intercepts, right? So to find, typically I start off with the y-intercept. To me, what's somebody's favorite color? I'm just curious if you guys are there. To me, the y-intercept is easier to find than the x a lot of times. So I'll start with the y-intercept, all right? So to find the y-intercept, we set x equal to 0. So if we set x to 0, we get negative 5y equals 0, divided by negative 5y equals 0, okay? So if the origin is the y-intercept, then that's also the x-intercept. To find the x-intercept, we set y to 0 and solve, and in this case, again, we get x equals 0. So it has one intercept as the origin. It's going to be 0, 0. Okay. So then it should be a line through the origin. Now, if we're asked to graph this, so we have one intercept. So we would need a second to verify at least a second point on our graph, right? So, all right. So I guess I can make this the first official Easter egg. Can somebody give me a second point on this graph? We have 4x minus 5y equal to 0. My clock right now is about to say 3:33, so I'll leave this Easter egg open until 3:35, which is like, that's a solid 2 minutes. But if somebody can give me another point that's on this graph, okay, I can give extra credit for that. This is just kind of an attendance check to see who's really listening. Okay, but it has to be some point other than what I'm about to give. So I'm going to let x be 3, for instance. So when x is 3, let's see, 4 times 3 is 12. Let's see if we did 4, 5. Let's do 5 just so we can get some clean numbers. So if x is 5, all right, that's 20. Subtract, we get negative 20. So negative 20 divided by negative 5 is positive 4. So when x is 5, y is 4. So another point would be 5, 4. All right? So we have 2 points. We have the origin, and we have the second point that we found. All right? So then we can just plot those points on the graph, connect them with the straight line, and that'll be our graph. See, we have it right here. So we plotted the origin, we plotted the second point, we connected with the straight line, and that's it. So a graph like this, the domain is the very left to the very right. So how far left does it go? It goes to negative infinity. How far right? It goes to positive infinity. Again, and the range is the very bottom to the very top. So how far down? Negative infinity, positive infinity. So again, both the domain and range in this case, they're both all reals. Okay. So I got about another minute on the Easter egg that I offered a few minutes ago. If nobody's there, then I will keep going. All right. So an important characteristic of a straight line is the slope, a numerical measure of the steepness of the line. Geometrically, this may be interpreted as the ratio of the rise over run. So slope is rise over run, and these things. To find the slope of a line, we use 2 points on the line. And then it's the change in the y over change in x. And that's what we mean by slope, or the steepness of the hill, or these kind of ideas. So the slope through a pair of points, so we have x1, y1, and x2, y2. Again, slope is going to be rise over run, which is the change in y over change in x. Here, let's do this. So slope. Right. So the slope, which is this m, which is rise over run, which is the change in y over change in x. This is y2 minus y1 over x2 minus x1. This is what we mean by slope. So when using the slope formula, it makes no difference which point x1, y1, x2, no difference which point is used. However, we have to be consistent. So if we do x1, y1 first, then if we do y1 first, we need to do x1 first, and vice versa. If we do y2 first, we need to do x2 first. But don't do y2 first and then x1 first, and that'll really throw things off. Okay. The slope of a vertical line is undefined, okay? So a little bit of information on that. So the slope of a vertical line is undefined. So if we have some number over 0, we want to knock that out. So we do KO. So that's going to be undefined. So whenever we divide by 0, it's undefined. But if we have 0 over some number, this is okay. This is equal to 0. Okay. All right, does anyone have any questions? That's good. When x is 4, then y is 4 by 5. Oh, Mr. Cunningham, I see it. And 3:35, yes, you did get it in time. Let's see. Okay. It's 4. Okay, I see that, Mr. Cunningham. So you have 4. Okay. I gotta log these a little bit better, but we will go with. So Mr. Cunningham got extra credit for that. Let me see if I can log this. So I'll go like this. And I just want a copy of this so I can pull it up later. Alright. And I want to save it. Alright, so I'll save that for later. Okay, so we got one person, he actually got it. The timestamp has that he got it in time, so I'll give him credit. He gave me one x value, he found the corresponding y. He found the additional point. Let me make sure that's correct. 4 and 4 and 5. When x is 4, 4 times 4 is 16. Uh-oh, I might have to take that back. 16 over 5 is not 4 over 5. Uh-oh, Mr. Cunningham, I can't give that to you. No, that's not correct. I can't give that credit, so I have to delete that. So let's grab that. Yeah, that's actually not correct. Or if it is, you'd have to convince me of it, but at first glance, it's not correct. Let's go here. So sorry, Mr. Cunningham, I cannot give you credit for that. It was not correct. All right. So moving along, we are still moving. All right. So it says find the slope of the line through the given points. So if we have these 2 points, now typically when I'm finding slope between 2 points, the points are that part is over. Yeah, those are done. Sorry. Okay. So typically when I'm trying to find points or plug them into the formula, first every time we use a formula we should write it down. So it says find the slope. So the slope between 2 points is going to be y2 minus y1 over x2 minus x1, right? And when I get a set of ordered pairs, for me the easiest thing is just go ahead and label it x1, y1, x2, y2. So I just quickly go x1, y1, x2, y2, right? So if we do that label, now it should be clear how to plug it in, all right? So that means the y2 should be negative 3, the y1 is 8, so it's going to be negative 3 minus 8. Then it's going to be 2 minus a negative 4. So we can see that below in the red and green, the red and blue. All right, so negative 3 minus 8 is negative 11. 2 minus negative 4 is double negative is positive, so that really is 2 plus 4, which is 6. So then ultimately the slope is negative 11 over 6. So what this means, this is the rise over run. So if we start at whatever point is on our graph, to get to the second point, because remember for a line we need 2 points. So once we can choose either one of these points, and then the slope tells you how to get to a second point on the graph. So it's saying that the rise is down 11 and then right 6. So if we start at either of these points, go down 11 and right 6, plot that point, that's the second point on our graph, then connect those with a straight line and we're good to go. All right. So moving along. Let's see, finding slopes with a slope formula. Yeah, we did this. So again, if you went x1, y1, x2, y2, so it should be negative 4 minus 7 is negative 11, but 2 minus 2 is 0. So notice we have some number over 0. Is this okay, or is this you knock it out? So we just said like a few minutes ago that this is some k over 0, so you knock it out, so this is undefined. Okay. All right, so if we did this one, if we quickly did x1, y1, x2, y2, so it's going to be the negative 3 minus a negative 3 over a negative 2 minus 5, so that's going to be 0 over negative 7, which is 0. So this is 0 over some number k, so this is okay. So this is equal to 0. Okay. So we have the slope of a horizontal line is 0, okay? It neither has no rise, it doesn't go up or down. It has infinite run, but no rise. So find the slope of the line of this line. So if we solve for y, right, subtract the 4x and divide by 3. So then we'll get y equals a negative 4 over 3x plus 4. So the slope occurs in front of the x. So the slope is a negative 4 by 3. It's going to be the coefficient of the x. This is called slope-intercept form. The plus 4 is our y-intercept, and the slope tells us how to get to a second point. So then once we connect the y-intercept with the second point generated from our slope, now we can easily draw, and quickly draw a line, this line. Okay. Notice that the slope is negative, so when we trace this graph left to right, it should go down. Let's see if we get a graph that comes up. Okay, we did not. So here it says we want to graph the line that passes through that point having that slope. Okay. So if we start at that point, if we're going to graph this, we would plot negative 1, 5. So what quadrant, here's another Easter egg, what quadrant is negative 1, 5 in? So if you're listening, what time is it? So it's almost 45. So when my clock gets to 47, if somebody could answer the question, what quadrant is the point -1, 5 in? So then if we have a slope of -5/3, so we would go down 5 and right 3. And let's see, and we'll get something like this. So first we plotted -1, 5. Oh, okay. I have Mr. Dawson. I think you got it. So Mr. Dawson, I see where you said quadrant 2. We went left 1, up 5. I can get down with that. All right. So then, Mr. Dawson, which class are you in? Oh, I see. Thursday. Oh, from the one this morning. Okay. Correct quadrant question. So that's +5 is in a Tuesday, Thursday at 8 a.m. Cool. So let's go like this. Let's log it. And let's do this. So again, these questions are open to anybody that's present. Just join in and try to get what you can. Save. Okay. Okay. Let me see something. Just a little music. I'll be right back. What is that? Are we gonna switch? What is that? Can we switch? Come on, switch. I want to see the code. All right, so we are back. All right. So we regraphed that. I think this is okay. So nothing super extravagant going on here. Okay, so then with the slopes, I see. Okay. So then a line with the positive slope rises as you trace it left to right. With a negative slope, it's going to go down when you trace it left to right. And when it has a zero slope, it's going to stay flat. It's neither going to rise nor fall. That doesn't work either. So we know that the slope of a line is the ratio of the vertical change in y to the horizontal change in x. So slope gives us an average rate of change in y per unit change in x. So if f of x is a linear function defined on a closed interval ab, then the average rate of change is going to be y2 minus y1 over x2 minus x1. Okay, that's all this is saying. So, yeah, that's okay. So in this example, we have, let's see what's the time. So it says in 1980, the average monthly rate for basic cable TV in the States was $7.69. In 2008, the average monthly rate was $46.13. We're going to assume that it's a linear relationship, and we're going to find the average rate of change in the monthly rate per year. So then it says graph as a line segment and interpret the results. Okay. So it seems like we have two main pieces of information. It says that in 2008, oh, wait. Let's get some better music. That music is killing me. I'm coming, gentlemen. All right, we'll let that play. Okay. So it says in 1980, right? It was $7.69. But then it said in 2008, it was $46.13. So we just want the slope between these 2 points. So we can do something like the following. We can go ahead and label them x1, y1, x2, y2, right? So then the slope is going to be y2 minus y1 over x2 minus x1. So that's going to be the 46.13 minus the 769 over 2008 minus 1980. I'm going to continue over here. So let's break out our calculator. All right. So let's just do the. So we're just going to say the top. I'm going to go ahead and do this calculation. The 4613 minus 769 divided by 2008 minus 1980. So it looks like it went up by $1.37 per year. So it looks like it increased by $1.37 per year. Let's see if this matches with the notes. So they get the 137. So the line through the order pair rises from the left to the right, therefore has a positive slope. So the monthly rate for basic cable increased by an average of about $1.37 per year. Okay. From 1980 to 2008. linear cost function has the form where the cost is going to be equal to mx plus b, where x represents the number of items produced, m represents the variable cost per item, and b represents the fixed cost. Okay, let's just see this in action. I think that'll be easier done in action. The revenue function for selling a product depends on the price per item p and the number of items sold x is given by px. The profit function is revenue minus the cost. So however much money you generate minus how much it costs to produce that, and that's going to be a revenue function. So this one is, we asked to see, it says assume that the cost of producing an item is a linear function and all items produced are sold. So the fixed cost is $1,500, the variable cost per item is this, and the item sells for this. Write linear functions to model first the cost. So it says the cost is going to be mx plus b, where m is the variable cost and b is the fixed cost. So then the cost of the function, the fixed cost is the $1,500, the variable cost is $100 per item, so that's 100x. So that's our cost function. Let's go ahead and find the revenue function. So the revenue we said was p times x, where p is the price per item. So it sells for $125 per item times x number of items. So I would imagine that the revenue function should be 125 times x. So then our profit is going to be revenue minus the cost. So that's going to be 125x minus the cost function, which is 100x plus 1,500. So let's keep going. So then we get the 125x minus 100x minus the 1,500. So then that's 25x minus 1,500 should be the profit. So then a natural question is, how many do we need to produce and sell in order to turn a profit? Okay, I think I will skip this one if somebody can tell me the correct solution. So how many, let me see. Maybe these are TVs. Say these are TVs, right? Or whatever the item is. How many of the items do we need to sell in order to break even? And then how many do we need to sell, to produce and sell in order to turn a profit? Okay. So let's see. The time is almost 8 after. So by the time my clock, I'll give you 2 minutes. By the time my clock says 4 o'clock, okay. So you got 2 minutes from now. Somebody could tell me how many of these items do we need to produce and sell in order to break even, and then how many do we need to produce and sell in order to turn a profit? Okay. So then I'm gonna pause it somehow. Let's see if I can come here. So I'm going to skip this one and let you all discover the solution on your own. First person to give me the correct solution, I will gladly give you points for that. And you have a solid 2 minutes now. Oh, and that actually closed out that section, so I'm going to leave that like that. Okay, so that was 2-4. So let's see what's next. It looks like we move on to 2-5. So we're going to go ahead and move on to 2-5. So I don't think anybody's gotten it, and I have another minute left on my clock for that last question. Nobody answered it? 20 seconds? I thought it was kind of easy. I just want stuff just for being present and actually thinking. That's okay. I think that's the answer right there. So those points are gone. Yeah, those points are gone. Okay. Let us. We would like to. Let's go back to the top. Let's copy. All right, so it looks like we are ready to start section 2.5. Okay. So then 2.5 are on equations of lines and curve fitting. Okay, so I think that's okay. So the point slope form of the equation of the line with the slope m passing through a point x1, y1 is given as this. This is something you should know. You need to know this. It's okay. So you should know this. Everybody should know this. All my students should definitely know this. It's point slope form of the equation of the line. That's when we're given a point and a slope. Then we can plug it into this formula to find the equation of the line. So it says write the equation of the line through this point, have the net slope. So again, every time, so we see we have a point and a slope, so we should use the point slope formula immediately. So the point slope is y minus y1 equals m times x minus x1, okay? So x1 is -4, y1 is 4, and the slope is -3. So then you see in red and blue, the different components plugged in. Then we just want to solve for y. And ultimately we get y equals a -3x minus 11. Okay. So if there are any questions, just stop me. You know, and I can kind of do it, answer kind of any questions. Since this is a live session, if you see something that doesn't look familiar or you have any kind of inquiry, just stop me. So now how do we know that this is the equation of the line through that point? Well, when x is -4, y should be 1. Notice, -4 times -3 is 12. 12 minus 11 is 1. Okay, so that checks out. So it says writing of the equation of a line through these 2 points. Okay, so we're given 2 points, so we need a couple of equations. First, we use a slope formula, which is y2 minus y1 over x2 minus x1. Okay, and ultimately we'll get that the slope is -6/5. Now we have a slope and a point, so we can use the point slope. So we can use either point for the point slope. We're going to use the -3 coming 2. I'll go ahead and work it showing that even if we choose the other point, we should get the same result. So let me choose, I'm going to say let x1 and y1 be 2, -4, right? And the slope is, we said it was -6/5, right? So then if we're using the point slope formula, y minus y1 equals m times x minus x1, right? So then if we plug in what we have, we're going to have y minus y1 is -4. So then we're going to have a -6/5 times x minus x1 is 2. So then that becomes y plus 4 equals -6/5 times x plus 12/5, and then ultimately y is going to be, it's a -8/5, -6/5 x minus 8/5. Okay, let's see if we get the same result. So now we chose a different point. Let's see if we get the same result. Oh, okay, we need to get it in terms of, so we will multiply the left and the right by 5, so I'll continue over here. So then we will say this times 5 and this times 5 and distribute the 5. Ultimately, if we add the 6x, we'll get 6x plus 5y equals negative 8. So this should be the equation of the line through those 2 points. Now let's do a quick check. 6 times 3 is negative 18, plus 10 is negative 8. 6 times 2 is 12, minus 20 is negative 8. Okay, so this equation works for both. Then 6x plus 5y equals a negative 8. Okay? So we chose the other point, but we showed that even though we chose the other point, it still worked. Okay? Let's keep it going. Slope-intercept form. So when we start with the point slope form and we solve for y, that'll allow us to finish in the slope-intercept form. This isn't correct. We gotta fix this. So actually the slope is the m. Okay, the slope is the m and the y-intercept is the b. So that's the classic y equals mx plus b. Again, this is something that we need to know. We should know. Okay, I'll be right back. Okay, so I know it's a good amount of people taking exams to know. No, we took ours for there. There is at least one group that might be online right now. I know that takes their exams tomorrow, then another group that takes theirs in 2 days. So I can open up a few minutes. If anybody had any questions about an upcoming exam that they wanted to ask, you can ask a few questions now. This would be a good time. So if you do have an exam coming up in the next couple of days, it's a good idea that one, you go through the study guide, at least be able to answer the questions on the study guide, and then two, be sure to bring your completed, notebook to the exam. Okay, let's get back to it. Okay, so let's see if we can find an example. So here we ask to find the slope and the y-intercept of the line with this equation. So all we would do is solve for y. I would subtract the 4x and divide by 5. So then we get y equals a negative 4x, 4 by 5x minus 2. So then the slope is negative 4 by 5, and the y-intercept is negative 2. So it's going to cross the x-axis, the y-axis at negative 2, and has a slope of negative 4 by 5. So here we ask to write the equation of a line through 1, 1 and 2, 4. Then graph the line using the slope-intercept formula. So if we want the equation of the line, we can use point slope where we're given a point and a slope, but we need to find the slope first. So we're going to find the slope. We got to use the slope formula, which is y2 minus y1 over x2 minus x1. All right? So then that's going to be the 4 minus 1 over 2 minus 1, which is 3. So it has a slope of 3. Then we can use the... Yeah, you can find b. That's fine. So we can substitute 3 in for m, and then choose one of the points for the x and the y, and then solve for b. So say we let x and y both be 1. Then we would have 3 plus b equals 1, so the b should be negative 2. So then finally the equation is going to be 3x minus 2. Let's see if that's correct. So then 3x minus 2. All right? Notice when x is 0, y is negative 2. When x is 1, y is 1. When x is 2, y is 4. So on and so on. So our points are there. So it says, use the graph of the linear function f shown to complete the following. Find the slope, the y-intercept, and the x-intercept. Okay. So slope is the rise over the run. So we need to find 2 points. It looks like the y-intercept is negative 1. It looks like the x-intercept is negative 3. So the rise will be negative 1. The run will be 3. So it looks like the slope is a negative 1 by 3. The y-intercept, where we said was negative 1, the x-intercept was negative 3, so it should be okay. Y-axis at negative 1, the x-axis at negative 3. Okay, so we said those. So an equation that defines this, so the slope is a negative 1 by 3, the y-intercept is negative 1. So if we use y equals mx plus b, where the m is negative 1 by 3 and the b is a negative 1, then we get our equation quickly. And the equation of a vertical line through a comma b is going to be x equals to a. The equation of a horizontal line through a comma b is going to be y equals b. So a vertical line means that x is always the same value no matter what y we choose. A horizontal line means that y is always the same value no matter what x we choose. Okay. All right. Let's see if we can what we can do. We have two distinct non-vertical lines are parallel if and only if they have the same slope. So whenever we see parallel, perpendicular, or neither, there's really a discussion on the slope. Okay, all we're really saying is tell us about the slope. So two lines are perpendicular, neither of which is vertical, if and only if their slopes have a product of -1. So if we say the first slope times the second slope, if it gives us -1, then that's what we mean by perpendicular. In other words, another way we've seen that, let's see, is one slope is the negative reciprocal of the other. That's the same as saying that their product is -1. Okay. Okay, I'm going to take a break. I'm going to leave this up as it is. If somebody first person to correctly give me the answer to this before I get back, you know, I might be able to give you credit. So take some time. It says write the equation in both slope-intercept and standard form of the line that passes through this point and satisfies the given conditions. So we want the answer. We want the equation of the line in slope-intercept form and standard form. Standard form is the ax plus by equals c. Okay, and the slope-intercept is the y equals mx plus b. So first person, take a couple of minutes. That can give me the correct solution to this. I'll give you extra credit. forgot it was going to cut off. So we can come back up. Okay, so hopefully you were able to write it down before it went away. So let's see what we got. Oh, nobody got it. Okay, well, that's the end of that. So it says the slope-intercept form, it says parallel to this line, passes through that point. Okay, so if we're going to be parallel to this line, right? That means we need to have the same slope, so we need to find the slope of this line. So if we solve for y, we're going to have 5y equals a negative 2x plus 4. So then y is going to be negative 2 over 5x plus 4 over 5, right? So that means our slope should be negative 2 by 5. So then if we plug that in, ultimately we'll get something like this. So we have the slope as a negative 2 by 5, right? So then we use the point slope form, y minus y1. So then ultimately we'll get this here. Okay. So then if we want to be perpendicular to this, we find the slope, and ours needs to be the negative reciprocal. So our slope is should be a negative 2 by 5. Oh well, theirs was a negative. Let's see, let's try. Theirs was a negative 2 by 5, so ours is a positive 5 by 2. Okay. So I think that these aren't too terribly bad. Just kind of work on and see how you can do it. If you have any questions, just come up later and ask me. Okay. So we have in this example, I'm finding the equation of a line that models data. So we have average annual tuition and fees for in-state students at a public four-year college are shown in the table for selected years and graphs as order pairs, where x0 represents 2005, 1 is 2006, and so on. Y represents the cost in dollars. This graph of order pairs of data is called a scatter diagram. So that's this. So it says find the equation that models the data. So the points lie approximately on a straight line. So we want to find a linear equation that models the relationship between these. So we're just going to choose 2 points. We chose the 0 and the 5492, and then we chose 5 and 7605. We chose those 2 values. And then we found the slope. So we would say that 7605 minus the 5492 divided by 5, and we get $422.6 per year. So we have a y-intercept of 5492 and a slope of approximately 423. So then we can just jump straight to y equals mx plus b. So then we would say y equals the 422.6x plus the 5492. should be the equation of the line that goes through approximately all of those points. So then it asks us to use the equation for part A to predict the cost of tuition and fees in 2012. So 2012 corresponds to 2012. Okay, so 2 more years. So if x is 7, so if we plug x equal to 7 into our equation, we get the 8450 point. Okay. So some guidelines for modeling: make a scatter diagram, find an equation that models the data for a line. This involves selecting 2 points and finding the equation of the line through them. Okay. So it asks us to use a graphing calculator to solve. We write an equation with 0 on one side. Then we graph So as we see in the figure, the x-intercept of the graph is -12, so the solution of the equation is -12. Right? So it's this, is that the end? That's the end, that's what he's going down. So we're saying that x equals -12 should make this equation true. Because we set it to 0, so when we solve, whatever gave us the 0 was going to be the solution of the equation. All right, so we will end the first session there. We'll take some time. I probably won't start the second one today, so I'll let the comments stay up for a day or two, and I'll probably pick this up come Thursday. So Thursday, somewhere again between noon to 5, I plan on doing a similar session. Okay, so I didn't really get a lot of participation, but that's one of the 5 videos I think that we're going to do, at least attempt to do for this. Okay. And so with that, we will end the session here. And so from one beautiful mind to another, enjoy the rest of your day.